Good morning today. Good morning all. Today we are discussing the some of the physical properties and physical state of the some of the elements of the 15th nitrogen family. So first of all the phosphorus. In the top one shows the white phosphorus structure, and the white phosphorus are exist in a tetrahedral geometry, and but even then the bond angle it is 60. That's why due to the ring strain, they are white phosphorus is more reactive and it's readily react with the air and to form the white fumes like P4O10. And the last bottom of the slide shows the red phosphorus structure, and in the red phosphorus is obtained by heating the white phosphorus at a very high temperature 673 Kelvin, and white red phosphorus is again a tetrahedra P4 tetrahedra which is linked together in a manner as shown below. Okay, so in the white phosphorus it is very reactive. That's why the we can observe the fumes in a the especially in cemetery. This is mainly due to the reaction of the phosphorus with the air. Now we are moving into the some of the compounds of the 15th group. First of all, the binary hydrides of the 15th group. So we can see that NH3, PH3, arsenic hydride, antimony hydride and bismuth hydride. For the nitrogen family, the molecule exists in a tetrahedral geometry, and the shape of this hydride it is pyramidal in shape. Since we know that the hybridization of the NH3 it is sp3. So the bond angle is 109.28 minutes. But here for the ammonia it is 101.7. This is mainly due to the presence of the lone pair. Due to the presence of the lone pair bond pair repulsion is exists. That's why the bond angle is reduced to 107.8 degree. And as we move down, the bond angle is in decreases. For the ammonia it is 107.8, for phosphorus it is 93.6, for arsenic it is 91.8, and so on. So as we come down, the bond angle is decreases. This is mainly due to as we come down to the group, the size of the central atom, increases. So the lone pair of electron is diffused in a large area. That's why bond pair lone pair repulsion decreases. So the bond angle is also decreases. Then when we moving into the boiling point. See here in the EH bond dissociation enthalpy and the thermal stability and the bond dissociation enthalpy. So the bond dissociation enthalpy decreases. That means NH bond is very powerful and pH bond is little bit weaker, and ASH bond it is weaker similarly. So as we come down, the bond dissociation enthalpy decreases and the stability of the hydride also decreases. That's why the reducing capacity are the increases as we come down to the group. Okay, I explain once again. The stability of the hydride of the nitrogen family decreases. Also, the bond dissociation enthalpies also decreases when we move down to the group. So that's why the reducing capacity of the element increases as we down the group. This is mainly due to the NH bond. NH bond is formed by the overlapping of the p orbital and the s orbital of the hydrogen atom. As we come down, the size of the atom is increases. That's why the s orbital, the effective overlapping of the p orbital and 1s orbital of the hydrogen atom decreases. That's why as we move down the group, the sharing is less. So we can donate the hydrogen readily to the element which is approached. That's why the reducing capacity of the element increases as we move down the group. Then we moving into the boiling point. This is the boiling point. See here in the graph, ammonia has the greatest boiling point, and as we move down to the group phosphorus, it is very less, and for the arsenic and antimony it is higher. This is mainly due to, in the case of the ammonia, a polarity is developed between the nitrogen and hydrogen due to the electronegativity difference. That's why the intermolecular hydrogen bonding is existing in the ammonia. So due to this hydrogen bonding, the ammonia has highest boiling point. As we move down, that is in the group, that is in the case of the pH3, the size of the phosphorus is higher than that of the nitrogen. That's why the ammonia, the NH3 has lesser boiling point. And similarly, arsenic and antimony, in the case of the arsenic and antimony, it is there is a small increase in the ammonia, and this is mainly due to the van der Waals force. And we have already discussed the reducing point. And next is the basic property of the hydride. As shown in the figure, in the bottom figure, we can see that the basic property of the hydride is increasing in the order as ammonia greater than phosphorus, greater than arsenic, and greater than antimony. So the stability decreases and bond dissociation energy is decreases down to the group, and the the basic properties also decreases. Only one property which is increasing is the reducing property, and boiling point also is decreases when we move down the group. Thank you.